Hello everyone. Welcome to Conference 42. My name is Nelloru and I am a lead guideware developer, Marquee Technology Solutions. It's an honor to be here building high performance financial APIs with Rust. I'm going to talk about claims management at scale with high performance financial API. Rust is great for API. It allows easily developing or generating open API documents and clients as well, both inbound and outbound services. It is actually is not a direct programming language, but involves the claims management if it comes to administration and management. Rust financial system handling over dollars annually. So the agenda. So what is how Rust impacts on financial services? When it comes to the impact on financial services, the main financial service for one imperative. So understanding the unique challenges of building mission critical financial APIs and while legacy approaches fall short. So when it comes to legacy in-house projects, there are a lot of complexities when to fit into the digital world. So to fulfill this one, so Rust is introduced high performance microservices and APIs so that we can achieve Rust key advantages for financial applications. Exploring memory safety. So here when you are creating the objects and nullifying garbage collection, so it will be more safety that it will find out that traversing from both directions and zero cost abstraction. Once it so everywhere you are using the same so that it will give zero cost abstraction and fearless concurrency in financial context. So when it comes to like earlier we are having concurrent exceptions with multi parallel threadings. So every time it will get deadlock. So this we are going to say like the fearless concurrency in financial context. So you won't get such type of complexities. When it comes to real world performance metrics and case studies, with Rust examining concrete outcomes from Rust forward claims, management system processing, $350 billion annually. Yeah, so when it comes to implementation partners and integration strategies, practical approaches for building and developing Rust financial APIs in production environments. When it comes to the security and compliance and feature directions, giving a clear path to address financial specific security requirements. Next for tech. So it is giving the clear path so that we'll get the security as well as the feature directions. So, as we discussed, what is the imperative in the performance perspective? So we already discovered, we already in the last page, we have seen that it will give the zero complexity when it comes to the thread safety and the speed requirements. So today's world, everyone is following the agile methodologies so that these Rust APIs and all will support. Like if you see any product, we are getting with the libraries with as a skeleton. So we are going to use that as a customization so that like in case of speed requirements modern customers expect instant claim decisions and immediate fund access while companies global operations. So especially in the claims management earlier to process the check pending approval, from there it will go awaiting submission, from there it will go for issues, then it will go to the clearance. So the process and all it will take at least 3 to 10 business days. Now this one with Rust, the speed requirements in the sense like a sub-second response we are receiving. Of course, like the clearance and the it through batches it will happen. So probably we'll get in a day or short. But when it comes to the security imperatives with Rust, systems handling billions in transactions required bulletproof protection against increasingly sophisticated attacks targets memory vulnerabilities. So with especially if you are taking insurance domain, so we are using the security. So for example, if you are doing any change in the claim, or if you are adding some coverage or modifying something in the fields of exposure or in the process of check, immediately the change will go to the ISO. From the ISO, again there are services like LexisNexis and other services, so that we'll get that if it is a fraudulent claim, subsequent response we receive that subsequent. We can say like a security imperative. That means we had security wise good performance Yeah. So reliability mandates. So financial APIs must maintain 99.99%. Sometimes we can say 100%. But in real world, it go up to some are 99.99%. So uptime while processing millions of daily transactions with perfect data integrity across distributed systems. If something is getting failing, so entire world is face the problems. We have seen that recently, and their Amazon service, all flights are delayed. So this type of things in the financial sector with rush to it was never happened. Scale challenges. Modern claim systems must handle, as I said, like 26 million plus daily results requests while maintaining the sub 100 milliseconds response times across global infrastructure. So all the legacy systems earlier, they have implemented with core technologies like Java, .NET, Python. They struggle a lot of issues, and sometimes they're not meeting their demands without significant over provisioning, creating inefficiencies and reliability gaps that directly impact business outcomes. Financial institutions need a fundamentally different approach to API development. So why Rust for financial services? As I said, Rust provides a unique combination of performance and safety guarantees that makes it exceptionally well suited for mission critical financial applications. It eliminates entire classes of memory errors without runtime performance penalty, preventing bullet overflows and user after free vulnerabilities that plus systems. If it C plus, there we have introduced object-oriented programming. That means actually the garbage collection. Whenever you are performing small operation within the method, when you go to execute the control, there intentionally it will create the objects environment. So it will fill once it will fulfill that business logic, immediately it will get out from that method. The all the variables which are used inside method is garbage collected. It will get freed the memory. So that memory will be used upcoming for the next statements execution. There we are creating the new object. Those objects will again use and the same process will follow. And the zero cost abstraction. If we see, as I said, we are having like in case of claims or policy or billing or contact manager. So there is a couple of products, like especially one of the leading product is Guidewire, and similarly we have some other competitors. But here they're providing the zero cost abstraction. That means everything they have defined. So we need to customize the code what they have provided with that typecast and all. So we won't get more issues. That's what we are saying, zero cost after. Even if you are customizing, finally it has to go the SOAP type. So that time we won't get any issues like the compatibility issues. So when it comes to the zero cost abstractions, I can build high level business logic without performance. So taking any performance. So we can get good performance when we are using the abstraction. Fearless concurrency. As I said, like there is no deadlock in the performance issues and no hanging out the application, a subsequent response for the each and every request. So even if you are processing 26 millions of requests every day, so without concurrent issues, we can yeah, type-driven development encode complex business rules in the type system, making invalid states and unrepresentable errors before deployment. So most of the type-driven things are handled at the compile time. If you are expecting the application kind of errors, those things they're making it as invalid and they're processing as requested. So to perform the business logic correctly. Nation of safety and performance has led it to adoption by major financial institutions for mission critical API systems. So what is the measurable impact on the performance metrics? So now if you see that like the processing time, it is detected from the legacy system. So the digital world with the Rust, it is almost 85% reduction. They reduce the time so that we'll get the performance, yes, subsequent response. Everywhere. More than 26 millions with VA gateway handling 26 million daily requests with consistency of 90 milliseconds response. That means across global operations. So the accurate system of the performance wise it is giving earlier it is 99.74 to 99 point below 99.74 earlier. Now it is moved to 99.91 sometimes most of the times and achieving the results representing a reduction of 14.9 hours of downtime and critical financial hours. That it will show the desktops and everything there. Now, if you see all the virtual machines came into the picture, significantly lower CPU and memory requirement and 40% infrastructure cost saving while improving performance. These metrics comes from aggregated data across multiple major insurance and financial institutions that have implemented Rust-based claims processing system past 3 years. And the consistent pattern of improvement demonstrates that trust performance can translate directly to business value in financial contexts. So, what are the challenges? When you, as I said, like the fraudulent claims or fraudulent request, we can easily achieve with a major insurance carrier needed to analyze 140 data points per claim across 810,000 daily fraud signals, while the sub 100 milliseconds response time to enable real-time claim. So once he created the claim, so it will go find checks like every checkpoints. There are 140 checkpoints. Yeah, all these 140 checkpoint it is crossing within 100 milliseconds. So what is the Rust solution? Implemented asynchronous. The asynchronous fraud detection means so whenever you are going with the transaction, so irrespective of the services, it will go and complete that transaction. Meanwhile, whatever service is called, it will get updated as asynchronously. So Rust asynchronous waiting with the Tokyo process multiple fraud signals concurrently with maintaining strict memory ports. We should not lead memory leaks. For that, we are using that concurrency. Zero copy deserialization with the reduced overhead for JSON parsing. Most of the things like it is a native language. So we'll get the custom memory pool estimate. What is the results if we are using the Rust solution? The challenge is so 99.96 of fraud checks completed in under 80 milliseconds. Why we are missing 0.04? So every day the hackers are coming with different techniques and technologies. It is a challenge for the major carry insurance carriers. So every time they're coming with different releases to overcome the with the hacker ideas and techniques. The false positive rate reduction by 31% through more sophisticated algorithms enabled by Rust performance. Every day, the data analytics, they are in different logics to get the more throughput so that it will go, the performance, it will give the better performance. Yeah. System handles 4 times traffic spikes without degradation. 70% straight through processing rate for eligible claims. So the step rules mainly will play the major roles in case of claims applications. So when it comes to the memory management, so each and everywhere we have the memory related errors and unpredictable latency spikes. To overcome these, so we have to follow the techniques like we have to clean up the garbage collections and runtime so that we can achieve these latency issues. And when it comes to the safe abstraction, so always we have to use the loosely coupling so that we can get the safe abstraction. So memory safety, impact and financial system. In traditional garbage collected language like Java, financial systems experience unpredictable latency spikes during collection cycles. C plus systems risk memory corruptions that can lead to catastrophic failures. Rust eliminates both problems through compile time enforcement of memory correctness without runtime overhead. So this Rust, all the things are eliminated during the compile time itself. So the predictable performance are shown in the diagram. Characteristics of Rust allowed us to eliminate the 99.19% latency spike that were causing transaction timeouts during peak periods. So when it comes to the bundle, commit the transaction database during the time. So how we can say the fearless concurrency? As I said, the golden systems in the legacy applications we are having, sometimes we have to wait for more than 10 minutes to complete the transactions. So some people they used to do multiple times to complete their transactions. And if it is not succeed, they'll come for the next day and they'll try. But when it comes to the Rust, We are seeing that second response, like the thousands of concurrent requests while maintaining data consistent across shared resources. Traditional approach force an unacceptable trade-off. So, what are the problems with the traditional approaches? If you go with the coarse granular logs, safe but creates bottlenecks. When it comes to the fine logs, better performance but risk deadlocks. Lock-free algorithms, highest performance but extremely errors. How we are going to achieve with Rust solution? We are using the type level thread safety. So every time the compiler prevents data rises. So during the compilation itself, the one which is bottlenecks in the traditional approaches. And here we are going to send it. So whenever it is required dependency, so always we'll go with the explicit thread safety guarantees. Guarantees that means concurrent threads it won't involve and we can achieve expected result within the span of time. So, it is not dependency. We'll go for the either async and wait. That means it no need to wait for that one. Once we'll get the response, automatically it will get updated into the system. So it will through synchronous. We are going to get the high performance cooperative multitasking as well, and safe communication between processing stages. So with these approaches, whatever traditional approach, bottlenecks and deadlocks, all these things we can achieve through trust solutions. In production financial systems, trust concurrent processing throughout improvements are three way first ecosystem for financial API or Rust ecosystem for financial APIs. Ecosystem provides a rich set of libraries, frameworks, especially beneficial for building financial services applications. So asynchronous seeing the high performance. If we see that Tokyo production grade asynchronous runtime enabling thousands of concurrent connections with minimal overhead, used by 92% of financial trust applications to handle high throughput API workloads. And if you are using API frameworks, so it will managing the cost and also the fraudulent easily. Yeah, battle tested web framework with comprehensive middleware ecosystems both offer performance far exceed traditional options. Metrics and so each and every step we have metrics and monitoring, so when we can easily trace where the exact the performance the tracing we can achieve expected performance. So when it comes to the comprehensive instrumentation libraries for production systems, open telemetry example integration enables seamless monitoring distributed financial transactions. In case of database access, when it comes to the database access, so each and every table or view or row we are using the indexing so that we can get the like earlier if like the response we are getting more than 10 seconds with this index and tuned queries, so we are getting the subsequent response. The serialization for security purpose, each and everything we are serializing and sending the over the network. And in case of DCN, that means you could not able to call one which is shared with the serialization. Security, so we need memory safe cryptographic libraries providing high performance TLS implementation, critical for security financing data in transit with minimal overhead. Implementation pattern for error handling financial data. Error handling in financial system present unique challenges. Errors, as we discussed earlier, so these errors, most of the 99.9% errors, we are handling it compile time itself. So the remaining 1%, so with efficient programming with the Rust, we are eliminating it. So what is the impact on production systems? So financial institutions using Rust error handling patterns report. So 99.92% system availability and 94% reduction in unhandled exceptions. Improved error enables minutes enhanced complaints through comprehensive error audit trails. So, what are the integration strategies adapting Rust incrementally? Most financial institutions can't rewrite entire system at once. So, if you see in the market, all the ready-made, so we define the system automatically. We can integrate the 100% reliability software. We can integrate with the as per our requirement. requirement. So these proven integration patterns enables incredible adoption of it, and that is performance critical microservices. If you see the each and every program, we are using the microservices for the better performance, identify high impact bottlenecks in existing systems, and replace with the targeted trust microservices. Common candidates include fraud detection, payment processing, and real-time. This approach delivered 70% processing time improvement at a major disrupting core systems. So the API gateway and transformer implement API gateway, rate limiting, and protocol rest. This pattern reduced latency by 67% for a global payments provider while adding minimal to existing system. The gateway became the foundation for further Rust adoption. And foreign function interface expose Rust functionality to existing Java.NET application through foreign function interface bindings. This approach enables surgical replacement of performance critical components while maintaining with existing systems. One bank improved transaction throughput 3.2 times using this approach. Their Java 4 banking system. If you see the modern systems, earlier they started using that systems later in between if they're changing some requirement. So entire process again they have to start from the beginning. So to achieve that one, to overcome that problem, we have whenever you need, we can in that one and we can complete either within the it's iterative model. So even Rust also it will follow that iterative model so that we can achieve expected results and in the time and the product will be in the market having the so when it comes to security advantages that directly address financial industry requirements, those are memory safety guarantees. So we already seen that memory safety, like when you are storing the data, so it always 100% can achieve without any mismatch. So fall for compilation, foreign false interface boundaries. When interfacing with legacy systems, Rust provides safe abstractions or unsafe FFI code containing potential vulnerabilities to well-defined boundaries. This pattern has proven crucial for secure incremental adoption, right? And data isolation requirement, making it easier to multi-tenant. So financial interface unique security challenges like regularity compliance. We have different standards like CADSS, OX, DPR, and multi-talent data isolation requirement. It has to follow all these regulations and sophisticated factors targeting financial data. So as I said, like for in the right time, right product when it comes to the market, then only the product having the business value. Rust delivers measurable business impact through its unique combination of performance and safety guarantees. 85% faster processing and 99.991% uptime and 40% infrastructure cost reduction and incremental adoption in practical. So financial institutions can adopt through my API gateways or FFI without risky system rewrites. Ecosystem maturity provides production-ready libraries for all critical financial API needs, from synchronous processing to secure database access. As I said, in the market, so the skeleton, the whatever like 99% providing the skeleton as libraries. So we have to just customize in the financial systems. The what are the next steps in the Rust? So identify high impact performance bottlenecks in existing system as initial Rust target. Start with small bounded microservices to build team expertise so that we can achieve the performance. Leverage Rust memory, safety advantages for security